All right, continuing with some more examples here. Look at the example number 3. What's different? What do you see automatically is not the same as what we were just working on? That's right, it's written in standard form. It's not in slope-intercept form, so it's a little bit harder to graph whenever it's like this. So what do you think we gotta do? You got it. We gotta put it into standard form. Okay, so let's go ahead and change the first one. What should we get rid of first so that we can get y by itself? Well, the only thing actually that we have to get rid of is this x, so that's kind of nice. So subtract x from both sides. So we have y is less than negative x minus 3. I like to put my x in front because it just looks like slope-intercept form. Do we have to change our inequality on this one? Absolutely not, because we didn't divide or multiply by a negative number, so we're good to go there. Okay, how do we change this bottom one into slope-intercept form? Right, subtract x again. Okay, so we have y is greater than negative x minus 1. Okay, did we have to change the inequality sign on this one? No, didn't multiply or divide by a negative number, so we're good to go there. Okay, let's start going through the steps now that we can start going 1 through 3. Step 1, let's go ahead and plot our m and b. So let's go ahead and identify those first. Okay, what is our b in this one? You got it, negative 3. Our m is negative 1 over 1. Okay, how about this next one? What is the b in the red equation? Negative 1. What is the m in the red equation? Negative 1 over 1. Once again, you guys are going, oh, this is totally going to be a no solution. Well, maybe, but we haven't shaded yet. We have no idea. Okay, let's go ahead and plot the black equation here. So at negative 3 on the y-axis, negative slope, so that means to go down and to the right. So down 1 to the right 1, down 1 to the right 1. I'm going to go the opposite way just to fill up my graph. Okay. Step 2, decide what line. What is it? Does it have an extra line underneath? Nope. So it is dashed. Good. Perfect. Done so far. Okay, let's go ahead and do the red line. Negative 1 on the y-axis. Okay. Our negative slope again. Okay, down 1 over 1, down 1 over 1 to the right. I like to fill up my graphs a little bit so I can make my lines a little bit straight. Okay, step 2, let's decide what type of a line do we have. You got it again, it's just a greater than, so it's just dashed. Okay. Step 3 for both is we have to decide where to shade. Okay, I'm gonna do test points again, and then the last example I'll do the calculator. Okay, so let's do test points. What is our pretty much always our test point, unless it goes through this? It's 0, 0. You got it. So let's do test point for the black equation. All right, 0 goes into y. 0 goes into x. All right, so we have negative 0. That really doesn't matter. What is 0 minus 3? You got it, negative 3. Okay, let's see if this is true or false. Is 0 less than negative 3? Think about a number line. Is 0 less than negative 3? Does that make sense? You got it. It does not. That is a false statement. So do we want to shade the side of our test point? So do we want to shade over here? Would that make sense? No, it just said, dude, that was false. So let's go to the other side. Okay, so let's shade the other side. The opposite side of your test point. Perfect. Let's do the test point for the red equation. Which one are you going to pick? Okay, what if this line went through 0, 0? Would we be able to use it? No. So I'm going to just pretend that it did. Let's not choose 0, 0. Let's pick something else. I suggest you pick something on the axes. Okay, I'm going to actually pick this point right here. That is 1, 0. Okay, it still works the same way. I'm going to plug 0 in for y, and I'm going to now plug 1 into x. Okay, let's simplify. -1 minus 1 gives us a -2. Is 0 greater than -2? Is 0 greater than -2? Think about it on the number line. Is it bigger than it? Yep. So this is a true statement, so do we shade the true side? Absolutely, you always want to shade the true side. So that's located on this side. Oh. So I said earlier, we need to look for the region that overlaps each other. Will this ever, even if it continued, will this ever overlap each other? Absolutely not. So what do you think the solution is on this one? Right, if they never overlap, just like if they never intersect, it is a no solution. Okay? All right, let's go ahead and do the last example here, and then we're going to give you some try problems. Okay, top equation, no good, right? It's not in slope-intercept form, so let's change that real quick. All right, what do we got to do first? Get rid of that x, move it to the other side. So we're going to subtract 5x to both sides. So we have y is less than -5x minus 2. We can't combine those aren't like terms. Is y by itself? Yeah, that was pretty easy actually. Okay, let's go ahead and do the bottom one. Time out. Did you really need to do anything with that one? No. That one's good to go. It's just a special case, so you don't need to change that one. That one's already ready. Okay? All right, so let's go ahead and graph the black line by identifying the b and the m. The b in this case is what? -2, and what is our slope? -5/1. Okay, so let's graph that. -2 on the y-axis, and we're going to go down 5/1. I'm going to run out of space. I mean, it's a negative. I don't have enough, so let's do the direct opposite. So if we went down to the right, we're going to go up to the left. 1, 2, 3, 4, 5, and over 1. Okay, step number 2, decide what line. You got it. It's going to be dashed because there is no equal to part on that. We're done with that piece. Let's move to the next equation. Y is less than 3. Okay, what type of line is that? Well, let's plot 3 first on the y-axis because it says y. Is this horizontal? Is this vertical? Is this solid or dotted? So there's a lot of things to decide. Well, let's do this. When it says y is something to a number, that is a what line? You got it. It's a horizontal line. Decision 1 made. Decision 2 was, is it solid or dotted? Same things apply. Is there an extra line on this? No. So let's go ahead and dot this. Okay. All right, we're almost done. Now we have to do our shading. Once again, I showed you test points in the earlier one. Let's go ahead and use the calculator for this one. All right, let's go ahead and type into y equals our slope-intercept form. -5x minus 3. I'm going to type in my second one, y is less than 3. Okay. Okay. What if it was x is less than 3? Should we probably put that in our calculator? No, we can probably do that one by hand. But since this is y, we're okay. Okay, scroll all the way to the left, go to your flapping arm. How do you change it? You hit enter. We are looking for less than. Is that less than? No. One more, that's less than. Okay. We're looking for y is less than. Keep hitting enter. Is that less than? No. One more. Okay, hit graph. Okay, this is our black line, and here comes our red one streaking across. Okay, where do you see the overlapping? It actually should look darker on your screen. So where's the darker region? Is this it? No. How about right here, where my finger's at? Does that make sense? How about this one right here? No. How about right here? Yes. Both of the intersections overlap. A little shortcut for you guys is go ahead on your graph and shade just this area. Okay, if I was teaching you in person, that's all I would make you do in my class. So I'm going to go ahead and shade the darker region and that only. So that is our feasible region. Any points from there, if you plug them in, would make sense. Okay, so that's the examples. Let's go ahead and try some problems on your own, see what you can do.